Hey guys, how you going? Good? That's good. We got two more videos to go. Wow, it's getting there. Long online teaching. We did last 4 weeks, didn't we? Yeah. And you guys are away for a while now. I'm sure most of you guys want to come back to school. All right, let's start. Last one. I'm gonna cover section 8 and 9. Only section 8 is in your curriculum. Okay, I'll just go and cover section 9. I don't think you have questions about it. No, doesn't even cover the question. Okay, I'll just introduce it. And then if you study method for next year, you can use that. Good. Okay, determining cubic rules. Now we're getting rules from information, either graph or info they provide. We can be able to draw, writing rules. So they separate to 1 and 2 here. I'll just write down. The first option is when we know or when we have 3x intercept. That means 3 real solutions. Okay? That means same as 3 roots. It's all the same thing. That's the first case. So for example, 3x intercept is all the same word. 3. Let's say we have the intercept is D, E, F. Okay, then I can write down y equals A, dilation factor here, and then x minus D, x minus E, x minus F. We've seen this before, didn't we? Yeah. I'll give you the example, e.g., let's say x-intercept is 3 minus 2, 5. X-intercept is given. Then I can write down y equals, can I figure that out A from this information? No, we don't know, so I'll write down A. Obviously, we need more information out of it, but I can fill this up. X minus 3, order doesn't really matter in this case. Minus 2, therefore change, minus minus plus, and x is positive, so it becomes negative. Because the 5, you get 5 from x minus 5 equals 0. So you always put opposite sign. Or that makes 0, whatever the easier for you. So it's getting close. All we need to know is A. Alright, so the first information we have, or from the graph, we get 3 x-intercepts, and plus we need one more point. On that, doesn't matter where, usually we got intercepts, but we will be given, okay, one more point. For example, let's say that passed 0 and 2. So that cubic passed 0 and 2. So that is second support here, the first information and second information. Okay, all I need to do, just plug in when x is 0, y is 2. So here, y is 2 equals A, x equals 0, 0 minus 3, 0 plus 2, 0 minus 5. 2 equals A times minus 3 times 2 times minus 5. then 2 equals a minus minus plus plus plus, and then 10, 30, 30. So that's 30a 2. Therefore, a equals 2 over 30. I just made up number, so we got a fraction here. But all I need to do, going back and plug in, therefore y equals 2 over 30, x minus 3, x plus 2, x minus 5. Does it make sense for you guys? Yeah? It's pretty simple, straightforward. I wish everybody able to solve this question easily. Okay? The first step, plugged in your x-interceptors in that formula. Hopefully you remember that. Yeah? Must know. And then to get a, to get a, you plugged in x and y x and y from one more point. Then you will get a, and then you're able to write down full equation. So you all good? Okay. So I covered first type. So type 1. And now go to the second one. Okay. Type 2. When we know 2 x-intercepts from cubic, obviously I'm dealing with cubic, so we know only 2 x-intercepts. Sorry, means only 2 x-intercept exist. When do we get this kind of chance? One solution is repeated one, which means we will get square one like that. So y equals a x minus d square x minus c. We learned that before, wasn't it? Yeah. How did it look like? One and 2. Remember, we got the turning point looking one here, point of inflection here. That was repeated value, which is squared value. Therefore, D and E. Remember that? Yeah. In case, I'll go back and I'll draw that as well. We know A is positive now. Yeah, so I'll draw that. And then smaller number is minus 2, so it's minus 2, 3, and 5. Can you get that? Yeah. Okay. Let's continue. So all I need to use is this. Let's say, an example here. No, it doesn't have the example here. I'll go and check. Repeated one. Okay, here. Y equals, no, we need to get the information. Let's say we have graph now. I am using page 34. We did it and we get that graph. I'm going back to get that. That's the information we have, the 4, 6, 1, 4, 4. When I look at it, I can tell this is what? Cubic. That's cubic. Good. And the first thing you need to go and check is how many x-intercepts do we have? 2, isn't it? Who didn't answer? Sorry. Okay. Nobody in front of me here. Okay. 4, the 2, and 4, x-intercept is 4 and 6, isn't it? And we know 6, that we got the point of intersection, inflection here. That means that's repeated factor, which means we have x minus 4 and x minus 6 out of it. I know the two factor we have, and since because of that is point of inflection or turning point, you can say, yeah, that is repeated factor, therefore that is squared repeated. Y squared repeated, x minus 6, and that means x minus 6 repeated twice, and I'll write down x minus 6 squared. So I can write x minus 4, x minus 6, you usually write on the front, doesn't really matter though, squared. Y equals, do I know any dilation factor? Don't know. Where do I get that? From here. Okay. I just figured out what is D and E. That's simple enough here. All good? Do you understand? Yeah? That's the downside. I can't really help you here. And then, so we know two x-intercepts, and we get that, through the whole. This question, I'm just assuming we have graph, and from graph, we actually get the equation. However, we still don't know what is A. Therefore, we need second information. We need one more point. Do we have another point? I use that. Here we go. I know y-intercept. When x is 0, y equals 144. Let's plug that in. When x is 0, I'll just repeat that again. 0 and 0, y is 144. 144 equals a times 0 minus 6, therefore it's minus 6 squared, 36, 4. 0 minus 4, oh sorry, it's minus 4. Is that right? Those 4, let me write it down. Yes, correct, yep. And then, when I do that, oh, actually it's when I do it, that is minus 144 and A. Therefore, A is minus 1. So we have to put minus 1. Y equals minus 1, which is minus x minus 6 squared, x minus 4. When you go back to that answer written as this form, x minus 6 squared, 4 minus x. Is it still the same thing? What they done? I can put this into negative here. So minus x plus 4. That's why they change it, but I'll probably write down this way. Okay, they are the same thing, just different way of express. Put negative front or somewhere in a factor. I can able to draw it, or therefore y equals minus. Same thing. That's all good. So I covered second part, type 2, which they don't have here. Okay. And let's go third type. So I did type 1. Hopefully you have type 2. And you also have the example here. Type 3. Type 3 is you have x-intercept. How many? Only one x-intercepts. So I'll just go straight forward. Y equals ax minus h cubed plus k. Do you remember? This one was y equals x cubed graph. Yeah. I just did it last class, wasn't it? You can go back and have a look. This one's positive, negative. So in this case, when x increase, what happened to y? Y decrease, going down. You can just draw one line and I can see that it's going down, negative graph. Y equals minus x cubed. This one going up, passing through here, y equals x cubed graph. I just check that again. Do you understand? And then what we did last class was this, moving h much and k much. This is moving x-axis, y-axis value. Therefore, for example, if I move y equals x minus 2 cubed plus 4, which means I move that minus 2, so inside of x we go 2 opposite, and then 4. I draw exactly same thing, but here. I don't know, I need to figure that out later, but we can draw that. Oh, y-intercept probably 4, no, 0, minus 2, so minus 8, minus 4, so that should, not this, minus 4. We can get that. I explained that last class. Okay. How do we get the y-intercept when x is 0? 0. 0 minus 2 cubed. So minus 8 plus 4, therefore minus 4. That's how I get minus 4. Okay. Anyway, we done that last class. If you're not sure, go back to previous lesson video and check one more. Okay. So I just explained why they actually are basically same pattern of graph. All they change is they add dilation. When you add the dilation, what happened? One more. Let's say this one was y equals 1x cubed, y equals 2x cubed, 3x cubed, bit more up. What about then half? Wider. Y equals 1 over 3x cubed, wider. That makes sense? Yep. So move that way. Exactly same as linear. 45 degree, up, down. And then 1, down, 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 eventually becomes 0, and then it becomes negative graph, like that. So that will explain enough. Okay, then I spent quite a bit of time because that was probably new thing. Yep, I told you last lesson. So let's say I'll go and find one. We have what's a good thing? Example 3. Rather than example 3, because you can actually do it by yourself. I'll go and check what we done yesterday. something clear number. Okay, let's say use there is no very clear number here. Oh, have to use example here. Example 1. Example 1. A cubic function has the rule this, the point this also on graph. So I have one information, and second, wow, it's already given. They could give me a different way, like one x-intercept and then given that, but yep, already given. Therefore, all I need to do, y equals ax minus 2 cubed plus 2, and that pass 3 and 10. All I know, since they have y equals ax minus h cubed plus k, only one solution I have, only one x-intercept. Hopefully you can figure that out now. And then all I need to do, when x is 3, y is 10. 10 equals a 3 minus 2, 1, cube 1 plus 2, therefore a is 8. Y equals 8, x minus 2, cube plus 2. Let's go and check that. Yes, I get that. Good. Example 2. Example 2. Can you try that question? Now it becomes much easier. I can see 1, 2, 3 x-intercepts type 1, and then plug 5 and 16. It's already solved pretty well. The other part is all algebra. Hopefully you're able to do it. Can you do that by yourself? Pause it and do it and compare the answer. Good job. And example 3 is the question. Okay, now this is a question we can use it. This is type 3. How do I know? When I look at the graph, now graph is given. Yep. That has the shape of either this or that. Point of go back and check for you. Here h and k, point of inflection exists, POI, which means you have only one solution. Happy with that? Yep. Only one solution, and that means you're gonna have y equals ax minus h cubed plus k form. Since we can only see one solution, please remember that. That is for the point of inflections happen. This is the characteristic, okay? For one x-intercept, or the graph has one solution, like that. And all I need to do, minus 2 and 15, so plugged in y equals a x plus 2 cube plus 15 from here to 15. And then I know everything except a, so we need one more point, in this case even minus 7. So when x is 0, y is minus 7. Y-intercept when x is 0, y is minus 7. I did that here. And oh, didn't solve it whole thing. Just compare, actually check the answer is correct. Yeah, it's correct. You should get a equals minus 11 over 4. Yeah. Therefore, y equals minus 11 over 4, x plus 2 cubed plus 15. All good? Yeah. And then example 4. So I just covered that type 3. Okay, that's pretty simple enough. It's all the same. You just go and figure out which type is it, and then plug into 3 types, 3, x-intercept, 2, and 1. Okay, and then you just plug in x and y from 1 point to get A. Done. I won't do that, but you can do it. I know minus 3, minus 1, and 2 x-intercept. Therefore, the factor is from here x plus 3, x plus 1, x minus 2. I get the 3 factors like that. Good. And then to get A, I need to plug in 1 point, which I have this 0 and 6. So I plug 0 and 6. And I get that. Simple enough. Trust you. Hopefully you can do that. All right. So section 8 is done. Section 8 is done. Section 9. I'll probably just continue section 9 here. I'll make that only less than 10 minutes one. Okay. Domain and range. You know domain is. Can you write it down in your exercise book? Domain is a function is a set of x coordinates. It covers x. Range is y values. We've done that. Domain is x values, range is y values. A particular function is covered. Good. Usually, we cover whole real number. Write down R because it's real number, all real number. Okay. Unless we have the limitation like this. In this case, there is a limitation. They use the word domain and range of a restricted cubic function. So they actually restrict they restrict domain, yeah, because range y values depends on x value. Okay, we actually restrict the x value, and then according to that x value, we will know the y value. So we plugged in x value to get that. In this case, square bracket included, we know that, don't we? That's included well, and dot like that, dots included. Curved bracket, exclude one or so, we use hollow circle. Okay, excluded. We done that, didn't we? We used it from quadratic, so we know that. I'm not gonna go that through. When they say domain include, when I look at that, the minimum value we can get from x is minus 5 to 3. So minus 5 to 3, and that include and include. So I know domain is this, yeah, and then range is y value. The lowest number I can get is minus 8. Highest value I can get is 10. And then they both include. Done. You understand? Yeah. And then inner curve, turning point there. Yeah. The higher turning point we call local maximum. The reason we introduce, you will use that for method 4 and specialize. And this one we call local minimum. Okay? And actual maximum number is actual maximum, because that is higher than the actual maximum number we can get. I mean, and then in this case, local minimum is also actual minimum number, same time. Okay, we just compare the number. There is no like calculation or anything like that. You just go and figure out what is highest and lowest. Actual highest number is actual maximum. Draw that will help you. You're able to draw one thing. Actual minimum number is actual minimum, and you go and compare those turning points, and the high turning point is also local maximum and local minimum. Actual maximum and actual local maximum can be the same or different like this. In this case, actual minimum and local minimum same. Depends on the graph, okay? It doesn't really matter. All right. Depends on how much they cover as well. If that goes all the way through, it covers more, we will have actual minimum, the other point there. Next, okay. So the function can be written this way. This is important, yeah? When you see f, means this is function, which means this has the rule, input output rule. And then next one, you write down domain. -4 to 1, which means minimum number is an x value, domain value, minimum and maximum. It will cover -4 to 1. Okay? It goes to real number. When they say codomain, it's like a range, but the range is within this set. Okay? So codomain is the actual domain that covers here. Okay? We can plug in the number and figure that out. Yeah. And then didn't write down actual codomain or range, where fx or y, same thing, y equals x minus 1, x plus 2, x plus 4. Rather than I draw, I actually use that solution. Okay. You can use a calculator to draw that. Yeah. So it's a calculator question. And then I know the three factors, and x-intercept is 1, minus 2, minus 4. Minus 4, minus 2, 1. At least I know that 3. X is positive 1, isn't it? Positive 1. Therefore, positive, it will have like that. Three solution. Yes. Good. And then use calculator. You can get that. Local maximum, local minimum. You're not able to calculate. I haven't taught you how to get local maximum and minimum from this level. You can use calculator to get. This is what? Local maximum. Good. What about this one? Local minimum. In this case, it's a local maximum and also actual maximum. Local minimum and actual minimum. Okay. And they put when x is minus 4, x is 1. Why did they put minus 4 and 1? Because they want to actually indicate smallest number and highest number. In this case, minus 4 and 1. When x minus 4, when you calculate it, y value is 0, so it's 0. 1, 0. And then you're able to actually draw it. Yep. And that's included 1, therefore I use close dot point dot here. The range, we just go and check the range. Ooh, they didn't really draw that well, because that's the domain. I think that's, shouldn't say. That's domain. Domain is minus 4 and 1. Okay, minus 4 and 1. Good. And range is what's the highest range? 4.1 here. And then minus 8.2. So that is range, domain and range. Good job. With the same thing, same way, they actually did that here. Actual maximum depends on the graph. Okay, so you need to just remember local maximum can be absolute maximum or actual maximum. Local minimum is absolute or actual. You can use both language here. And can you do that? Can you do that? I mean, I can assume that this skewed one. I'll just let you do this because it's all given here. You're probably able to do that. According to you done everything, I'll just do this. This is what I get. You can use calculator. Make sure you're able to use calculator. Good. Okay, then that's what I get. And domain is x value here, isn't it? So from x goes to real, or you don't have to really write down, domain equals 0 to 7. 0 to 7, include, exclude. Okay, that's what I get. And range is y value. Go and check what's the from lowest point, which is 0, 0, 0, so 0 to highest point 28. Check the y value, and that include, good. That's exclude. Range. That's how you write it down. You must know that able to do that, yeah. But you don't have to draw. You can use calculator. All right, good. We actually done. We done cubic. Well done, guys. So just put one more thing so you can summarize if you need it. It's type 1. Type 2. Type 3. Okay. Hopefully. When you've done that, please make sure you're going back to, you can do some of the assessment, but it's not due next week yet, okay? Assessment 6 is not due next week, so I'll give you one more week to do, so week after. So don't worry about that assessment 6 due, but you have test, so you need to go through quadratic, okay? Go and study quadratic this week, and when you come back on first class, Monday, isn't it? Monday class? Yeah. Come with some of the questions you're not sure. I am happy to go through together. Okay. I will just go through the first class. I will go through quadratics like assignments or other questions or concept. Just write it down, and then I'll ask you guys. You just let me know, and I will go through together. I'm happy to go through that day, and then Wednesday is your quadratic test. Particularly quadratic graph is harder for you. Okay, so make sure turning point and graphing, and from graphs to write down rules, practice that parts more. Okay, well done, guys. This is your last lesson through the online. We'll see you on Monday. Thanks. Well done. Don't forget like and subscribe. No.